I think girls will be wearing bangle, no? That bangle is what this ring. No. So this E bar due to charger ring. E bar on the axis of charged ring. No. I'll assume two elements, two symmetric elements. I'll assume it. Let this be theta, dE dash, dE dash. I think every point on a ring will be equidistant from point P. It is like some sort of cone, and there's a base of cone. So you take any point on the ring will be at the same distance from the point P. So I assume now two elements. Then what is dE dash? Let's define first dE dash. K dq by r square. Now you take any point on the ring, at what distance it will be from point P. Will be at a distance r only. I think cone ice cream now, summer season, very good. You take when you are before eating cone ice cream, this apex of cone. So here, what all the chocolate will be there, this circumference. You take any point on this, will be at a distance r only from the apex of cone. So look at now, r small r is a constant or variable now. It's a constant. And what is dq? The elemental charge. So let's go for the resultant field. The resultant field will be 2 dE dash cos theta. Okay, look at that cos theta also. It should be constant. So now in the integration, what all will come outside? 2k cos theta, or will substitute that cos theta also. What is cos theta? Capital R root of, what's like x by small r. No, x is also a constant. So I'll integrate now. This will be, so this will be d equal to 2kx r cube dq. Now what should be the limit? 0 to q by 2. Why not q? Because I assume two elements. I assume two elements. So 0 to q by 2. If I assume only one element, 0 to q, it will be. So solving this, the E bar will be 2kx by r cube, q by 2. So kx by kqx by r cube. Okay, let's substitute all the things. So kqx, what is small r? Small r will be r square plus x square to the power of 3 by 2. This is the magnitude of LT field, and now it will be the resultant field will be directed away from the center of the charge ring. Since a positively charged body, so the resultant field will be directed in this way. E bar on the axis. Then let's get into some mathematics. I wanted to know how actually that variation is. So when I plot the graph, Okay, the variation will be somewhere at a point, it will be maxima will occur. And the variation will be symmetric about you should touch that E maximum. The variation will be symmetric about the axis here. This is E bar. No, look at this one. At r small at x equal to 0. Sorry, this is x. Put x equal to 0. The field strength will be 0. Then as x increases, the field strength will increase somewhere at a certain value of x. It will be maximum. Then again decrease. Don't show symmetric about this point. Not possible. Because here 0, where it will be 0 again, at x equal to infinity, it will be 0. So the curve should not be symmetric about this maxima. I want this maximum field, and at what distance from the center on the axis will be maximum. So for that, shall we differentiate this dE by dx? Anybody differentiate and equate to 0? You'll get value of x. Differentiate field on the axis of ring. No. Anybody value x equal to? We did in gravitation, that's why I'm asking. Otherwise, I would have done. Value x equal to differentiate and equate to 0, you'll get the value of x in terms of capital R will come. R by root 2. And substitute the value of, okay, yeah, R by root 2. Then that E max, if you substitute that one, it will become 2 kq by 3 root 3 r square. Please do remember, you check the mains exam, you do have questions based on this. In exam, you can't derive, and again I'll differentiate, I'll equate to 0, then I'll substitute x equal to r by root 2, then I'll get this formula, then I'll use. By the time your competitor would have solved 4 or 5 problems. So you should know this formula, and you should know this formula. I'm making things clear. There's no other way. You may be very intelligent, but if you don't have some suitable memory, not possible. You may not get good score. Plus or minus root 2. Either way, no, it will be, yeah. So here, this is r by root 2. The field will be maximum here. We do have plenty of good questions. Do remember timing this data. So like this, the field on either side, don't think that field will be there. Even the electrostatic field will be present in this side. On either side, from the center of the ring, at a distance r by root 2, the field will be maximum. How it will be directed here? Towards right. What about field here? Will be towards left. Okay, this is about the field due to uniformly charged ring on the axis.
Sir, can you explain the limits, sir, in that? For dq, how it is from 0
So
to theta bit?
I assume two elements. So therefore 0 to q by 2.
Yes, sir.
So I took two elements, no?
Yes, sir.
Hmm?
Yes, sir.
Limits are as two elements are assumed. Okay.
Yes, sir.